This is Manoj, and I'm the host of this SLS talk. And I'd like to welcome everyone here in this SLS talk, episode 27. And we are very glad that our friend Mathieu Ravaut has accepted to give a presentation or give a talk about his research work. And the title is How to Make the Most Out of Abstractive Summarization Models. And I think he's right now in third year of PhD here at NTU, if I'm not wrong. And he has won several awards, especially the one that I remember is Data Science Fellowship Award. Mathieu, if I'm correct?
Yes, that's true. Right? The SCSE Singapore Data Science Consortium PhD Fellowship.
Yes, and really like to congratulate you, man.
Thanks.
So without further delay, I believe that this presentation is gonna be very, very good, and it's about summarization models. So I'm really actually excited as well, and I request all the participants to mute themselves before we start. Let me, and if you have any questions or queries, you can quickly write to the chat box, as well as you can place your query at the end of the presentation as well. So without further ado, let me invite our friend Mathieu Ravaut for the presentation. So the stage is yours, Mathieu.
Okay, thank you, Manoj, for this introduction. So hi, everyone. Today I will talk a little bit about my PhD research on abstractive summarization. So I'll focus on my paper, Summa Fusion, which was published at EMNLP 2022 last year. I'll just go into give some background context, describe the model, experiments, some extensive analysis, and a conclusion that we can draw. First, a little bit of background. Just about myself, I'm a third-year PhD student here at NTU SCSE. I'm in the NTU NLP group. I'm supervised by Prof. Jyoti and Prof. Sun. I'm also attached at A*R, I2R. I'm supervised by Nancy Chen. I'm currently doing an internship at Huawei Noah's Ark lab in Singapore. And my PhD research from day one has been on this following topic, which is abstractive summarization. So if you're not familiar with summarization, like the task itself, summarizing is quite intuitive. There are two flavors to it. There's extractive summarization, which will be restrained to copying things which are in the input. And there's abstractive summarization, which is more like a human would write a summary, and the summary can contain words and sentences which are not in the source. If I were to define abstractive summarization, a nice definition would be to compress a source text, so for instance, a news article, into a fluent, grammatical, informative, relevant, and factual summary, not constrained to only include elements from the source. And if you want to quickly toy around with summarization, you can just log into ChatGPT, give your inputs, and then put TLDR at the end. You should get something that looks like a decent abstractive summary. State of the art in abstractive summarization, honestly, including ChatGPT and recent very famous large language models like GPT-3, GPT-4, that kind of models, they rely on some or most of the following ingredients. So we have a pre-trained encoder-decoder sequence-to-sequence deep neural network. So two which are very popular in abstractive summarization are Pegasus and BART. Both of them were published in 2020, so around 3 years ago. And with such models, after pre-training, we would typically fine-tune them with whatever available supervision we have on whatever downstream data set we're interested in. So a very popular choice is XSUM, which is a new summarization data set. And then we would train, when we train these models, like either in pre-training or in fine-tuning, we train with maximum likelihood estimation and cross-entropy loss and teacher forcing during training. Now at inference, it's a little bit different. So at inference, we're trying to generate summary. So we need to pick a decoding strategy for autoregressive decoding. And such a strategy actually produces several possible summary candidates, right? So we have beam search, which is the most popular strategy. It typically leads to the highest rouge scores or blue scores in translation or bird score. There are many ways to evaluate text generation. It's a big research area as well. Or diverse beam search is another strategy with a bit more diverse summary candidates. You can also do sampling, like nucleus sampling, top case sampling. This is quite popular actually with ChatGPT. There are many other methods to decode the model. And one thing I've noticed is that there is large variance among candidates that you can generate with these models, right? So we're not really mastering the way we're outputting the summary out of these models, right? Which we're only approximating the best possible summary. And what we can do is like draw several of them and there will be a large variance. And what we can also define out of that finite amount of summary candidates we've extracted is something called the oracle, which would be, like, let's say you've produced 10 summary candidates. So you do beam search with beam width 10, you get 10 summary candidates. You can score each one of them. And the one with the highest score would be your oracle summary candidate. Oracle because it's actually accessing the target because we've evaluated its score. Right, so that's a bit of background on this research area. And so recently, there have been a few alternative ways to train abstractive summarization models, typically with sequence level second stage methods. So one popular approach is to, so such methods, like they give a different view to the typical framework that I described just before. So we're not training at the token level anymore, but rather, you know, we assume like we already have a model generating summary candidates, and this time we train at a sequence level and try to pick a better candidates. So the most intuitive way is to re-rank your summary candidates. So you can train a supervised re-ranker. So the SIM-CLS was one of the first papers to do this. There's my paper, summary ranker. There's Brio, which was also published at ACL last year and by the same authors at SIM-CLS. You could re-rank in an unsupervised manner. So I have an upcoming paper at ACL this year proposing this, which is called SumScore. Or you could just train, you could just do another round of training with your BART model or Pegasus model, but with a different loss, for instance, a contrastive loss. There are a few papers like Seco or Consum proposing such an approach. But in this talk, I'll describe the method we propose in this paper, Summa Fusion, which is a completely different approach, which consists in merging together or fusing together entire summary candidates. Because the thing is, the previous methods, like the re-ranking ones, for instance, they are typically bounded by the base model oracle, right? So let's assume you have access to 10 summary candidates, so trying to train a re-ranker to, you know, select the best out of them. Even if your re-ranker is perfect, what would happen is that you would select the best candidates, but that's it. You're not going to go further than this, right? So what if that best candidate was not even good in the first place? So that's a bit of the issue with re-ranking. So that's what we call the oracle barrier. And we want to break this. We want to possibly go beyond the oracle, the first stage oracle, and allow the model to produce like a second stage abstractive summary. So that's why we use the second stage generation model, which will fuse together first stage candidates. So fusing entire summary candidates was never done before, although there are a few research papers proposing to fuse at the sentence level. For instance, identifying important sentences in a source document and maybe clustering sentences in a given topic together and then fusing such sentences. But at the entire summary level, it was never explored. So how do we go about this? How do we design such a model performing summary candidates fusion? Well, so the immediate thing we can think of would be to get the source documents and then concatenate this with all the first stage candidates. But that would result, as you can imagine, in something of a very long length. I would have a huge block of text. It would be easily 2,000-3,000 tokens. And with standard models, which are limited by typically 1,024 tokens. I think ChatGPT is probably a bit more, like 2,048. Yeah, I mean, you see that there's going to be an issue here. So instead of doing this, we follow the fusion in decoder idea, which is to encode separately. So we encode the source and we encode each summary candidate, which is quite fast. In encoder decoder models, encoding is fast. The issue is typically decoding, especially if your output sequence, if your target sequence is very long. And then we encode separately and then we concatenate the representations. So that would lead to a unique long context vector of all the representations from which we'll decode. On top of this, we also include candidate level information. So there will be a special token to indicate the candidate position. For instance, in beam search, we have a score actually for each. We have a log likelihood score for each candidate. We also add a classification head to predict whether the candidate is the oracle or not. Much like summary ranker, which is a supervised summarization re-ranking model, was trained. So this is how the model would look like. So we set the bottom, we have our source documents. So again, just when I say source, just think about a news article. And then to the right of it, we have our summary candidates. So here, M candidates, each with their special token. And then we pass them to the encoder, right, in blue. The shared encoder, of course, is the same across all of these encodings. We get our embeddings. For summary candidates, we also pass them to the during training. They also go through the classifier, which will predict whether they are an oracle or not. Then we'll concatenate all of these embeddings. That's the fusion in decoding idea. And then we would predict, pass this to the decoder to predict the final summary. So that's the summa fusion model architecture. So it's more like an enhanced encoder decoder approach with multiple encodings. So in practice, how do we implement this model? So to generate the summary candidates, we use a Pegasus large, which up to recently was state of the art in abstractive summarization, specifically on news summarization. It's very strong. To produce the candidates, we use diverse beam search so that there's more diversity to our pool, to our initial pool of summary candidates. We take M equals 15 summary candidates for each data point. And for the language model encoder decoder, the backbone of summa fusion in blue here, this time we use BART. So we've experimented with reusing Pegasus or doing BART and BART, but it turns out that taking two different models, so crossing models, right? You produce summary candidates with one model, and then you re-encode this and regenerate new summaries with another one. It adds diversity and better quality to the summary outputs. And for the classification head, it's just a simple 2-layer NLP with really non-linearity. So during training, to enhance this training process, we'll also use something called input dropout, which means that we would randomly shut down the source or some of the candidates so that the model doesn't learn to, only rely on some candidates. Because one pitfall in such a model is that, this is a second stage model. So, I mean, in some cases, the base summary candidates are already quite good. So the model could easily fall back to just copying candidate one, for instance, right? You just copy this and that would lead to a decent output. If we're using, for instance, full shots, XM, Pegasus summary candidates, well, they already reached a rouge over like 47, rouge one, that's already a strong summary candidate. So to prevent this, input dropout is quite important. Input dropout, which comes in two flavors here. So we have source dropout. So we would randomly replace the source with the entire source with a placeholder token with probability P source. I think we use 0.2 during training. And candidates dropout. So we would sample a number of candidates between 2 and M. right? So that's the number of candidates we would keep, and we will replace all the others with, again, placeholder total. Right, so that's model design and the training process. I haven't talked about the loss, but once the model is set up, and we just train this in the standard first stage way, which would be just with maximum likelihood estimation with cross entropy loss and teacher forcing. Right. Now going to experiments and applying this model. So for experimental scope, we applied this model to 3 summarization datasets, which were selected for the high abstractiveness. Because by design, this model summa fusion is meant to tackle quite abstractive summarization tasks and not only copying, because there are two rounds of learning an abstractive summary. Right, the first stage, summary candidates, and then we give it another shot, pass this to summa fusion to again produce a new different summary. So it's designed to tackle very highly abstractive summarization. So we use XSum, new summarization datasets, which is BBC articles that we have to compress into 1 sentence. It's very abstractive. It's very noisy also, unfortunately. We use Reddit Tifo, which is a series of blog posts on Reddit. Typically very short sentences, but many short sentences. Again, quite short and abstractive summaries, not constrained to 1 sentence, but it would usually be around 2 sentences. We use Samson, which is a dialogue summarization dataset. Here, the source is quite short. It's typically a short conversation between 2 to 4 people, talking maybe like 2 or 3 times each, short sentences. And the summaries are very abstractive. I just would give an overview of what was the dialogue about. Actually, for the backbone of summa fusion, we experimented with both Dart base, just as a reference, and Dart large, and we trained it in full shots using the entire training data set, as well as in few shots, 10 shots, 100 shots, and 1,000 shots. To have an idea of how much supervision is needed to get decent summaries. So here are the results in full shot. So we use the Rouge metric, which is the standard metric in summarization, which is typically used in 3 versions: Rouge 1, Rouge 2, and Rouge L. So if you're not familiar with Rouge, Rouge 1 is unigram overlap, Rouge 2 would be bigram overlap, or like bigram recall. Sorry, more like unigram recall and bigram recall. And Rouge L would be the longest common subsequence. So you can see in this table the Rouge results on the 3 datasets. So our baseline Pegasus. First row is the Pegasus decoded with beam search. First 2 rows, and then DBS. So that's our input. That's Pegasus decoded with diverse beam search. So that's what we gave to the summa fusion. You can see in italic the oracle. So you can see that the oracle is very high. I like to showcase this. So look at XSum, for instance, the baseline Pegasus with diverse beam search, the first summary candidate. The Rouge one is 46.78, but the oracle will be 56.76. So if you have a perfect re-ranker, there's 10 more Rouge points to grab from re-ranking, which is huge. This is more progress than has been done in the entire field of abstractive summarization in 3 or 4 years. So in our case, what we see is that summa fusion large, so with Bart large, of course, performs better than the base one with Bart base. So in the following, we stick to Bart large, and we see good relative improvements on Reddit Tifo and Samson, around 2 to 3 Rouge points consistently. Especially on Reddit, it's 18% relative improvement. And the Rouge we get is not SOTA, but it's quite close to it. It's quite competitive with SOTA. Now looking at few shots. So in 10 shots and 100 shots, each time average over 3 pairs of training and validation datasets with typical framework. And what we see here is that, again, SummaFusion is able to push the rouge of the base summary candidates. It's quite striking on exam this time in few shots, right? On exam, it was not really improving in few shots. Actually, it was just pushing our baseline from like 46.8 to 47.1. But my intuition is that Pegasus on exam is already very strong, so it's quite hard to go further than this and produce better summaries, especially given the noise level of exam. Whereas on Reddit, it's a very difficult task, and the baseline Pegasus is actually not that great. So a second stage method would have more room, more ample room to produce a better summary, which is what's happening with SummaFusion. So again, we see good relative improvement on Reddit and on Samsung. And here's an overview of both few shot results and full shots on all three data sets on validation and test sets. So you see that, typically in 10 shots, the relative gain would be larger, not only on exam, but also on all of them. So it suggests that it's better at improving performance of lower quality summary candidates, right? Because in 10 shots, you have much less supervision. So, it's harder in the first place to have a good baseline. So that's where it makes more sense to use a second stage method to make the most out of this and try to push further your summarization performance. But rouge is not everything, and it's just one metric out of many. What's very important in summarization is to have a look at what's going on. So here's an example on Reddit Tifu. So you can see the source documents, which is like I said before, I described Reddit Tifu is more like a blog post, like a story, someone describing a bad event that happened to them in their life. It's actually a very funny data set. So if you want to work on summarization, I promise that if you tackle Reddit Tifu, you're gonna have a fun time. Some stories are hilarious. So you can see that this happened yesterday afternoon. He's been trying to dual boot Mac OS and Windows on his wife's MacBook Pro. But it didn't end well, right? In the end, the guy accidentally deleted the hard drive, lost all the data. The wife was mad. So poor guy. He describes a bad story that happened to him. In the second block, we can see the summary candidates produced by Pegasus with diverse beam search. So 15 of them. We don't have space to list all of them, but some of them are quite decent. The first one is pretty bad. Just saying got yelled at for 4 years. Third one is decent. I tried to back up my wife's files on a MacBook Pro, ended up deleting 4 years worth of data, right? The last block is the ground truth summary from this dataset. So try to install Windows on MacBook and ended up erasing everything without backing up and losing 4 years of my wife's work, right? And SummaFusion here predicts try to dual boot my wife's MacBook Pro with bootcamp assistance and ended up deleting 4 years worth of data. Right. So for instance, I've put in italic what it's predicting, which is not in the base candidates, right? So it's able to catch that dual boot term, which is quite important and which all of the summary candidates had missed, right? As well as bootcamp assistance. So that's called candidate subtractiveness. So abstractiveness means when you're predicting something which is not in the source, but SummaFusion conditions on both the source and the candidates. So here we define two abstractiveness, source abstractiveness. So the model producing words not in the source, and candidate subtractiveness, the model producing words not in any of the candidates. And here we're witnessing both of them, right? It's predicting expression not in the candidates and not in the source. And I would say that on that particular data point, SummaFusion works pretty well. Like to me, the summary is on par with the ground truth, probably even better. But surprisingly, SummaFusion summaries are not that more abstractive in terms of source abstractiveness. Right? So if we have a look at both for subtractiveness, source subtractiveness, candidate subtractiveness. So we compute percentage of new of 1 grams, 2 grams, and 3 grams, of unigram, bigrams, and 3 grams, which are new. Right. So that's how we evaluate subtractiveness typically. And what we see is that summa fusion actually lowers a little bit the source subtractiveness, but that's fine. I mean, the base Pegasus was already quite abstractive on this very highly abstractive summarization task. It was already quite abstractive, so summa fusion maintains some abstractiveness with regards to the source, and so quite importantly, it produces decent candidate subtractiveness, right? So we're not falling in that pitfall that it would be copying an entire, copying each time an entire summary candidate. That doesn't happen, as it's able to produce words which are not in any of the input candidates. So it has this desired behavior of double abstractiveness. So that's good to confirm this. Specifically on Redditify is quite striking. 21% of unigrams are not in any of the source candidates. Right, so now looking at an ablation of the model. So here we're just showcasing. First row is the main model on Redditify, and then we're removing some components. So what if we remove the candidate's classification head? What if we don't do input dropout? What if we remove the tokens? What if we do not feed the source at all? What if we don't feed the candidates at all? So you can see that the source seems more important than the candidates. If we remove the source, it's yielding quite lower Rouge score. We lose like more than 10% in Rouge. But if we remove all the candidates, it's just dropping by around half a point. And here's the concat baseline. So I think for this one, it was just taking the source, truncating it, and taking each candidate, truncating them, and concatenating all of them so that it fits into the 1024 tokens window, context window for Pegasus, right? And then just fine-tuning this. So that's a little bit better than Pegasus, but only a 26.9, still quite far below summa fusion, and not scalable. Like if you have long summary candidates, that would just not work at all. Right. Another ablation is in terms of how many summary candidates do we need. So here we played with that number of input candidates. So because the model is actually quite flexible, you don't systematically need to give all 15 or 20 summary candidates. So what if in a specific inference case, you only have access to like 3 or 4? The fusion in decoding is very flexible. You can just encode whatever number of summary candidates you have and decode the summary. That will still work. So that's why we did it here at inference. And we can see that specifically on XSUM, it's quite impressive that we really need all of the input candidates, right? If we give to reach the best performance, we will need all 15. If we have only like one, like none of them, or 1 or 2 or 3, the Rouge will be a bit lower, like not its full performance. In abstractive summarization, it's also very important to conduct a human evaluation. So in that case, we're asking humans we're showing humans random data points. So they have a look at the source. They also have a look at 2 summaries. So for each data sets, we did two comparisons. One is summa fusion summary versus the base Pegasus one. Another one is summa fusion versus summary ranker, which is another second stage abstractive summarization method, but just re-ranking. Remember, just trying to pick up a better initial summary candidate. And we're asking humans, okay, here are 2 summary candidates. Pick which one is more informative, more fluent or grammatical, or more factually consistent. Right, and in parentheses is the standard deviation over the results over 3 humans. So for each data set, there are 3 human evaluators. we can see that summa fusion versus Pegasus is quite a large difference. Like summa fusion is strongly preferred, especially on Reddit, for instance. And I mean, that's given the difference in rules that we've seen before, that's definitely not surprising. Usually large rules score differences correlate well with human judgment. On exam, the rules difference was much smaller, but we still see a sharp difference in terms of human evaluation. And now in the second subblocks, summa fusion also performs quite well compared to summa re-ranker. Well, on exam it's around the same, but on Reddit it still has the upper hand compared to summa re-ranker, and on Samsung as well. Lastly, so remember that one of the premise of this work was that, okay, with the re-ranker, we're bounded by the oracle. So why don't we do an abstractive second stage model that could potentially go beyond this and produce an even better summary than the first stage oracle? So here we check if that actually happens. So are we able to produce summaries which are beyond the first stage oracle? So we investigate this and vary things across 2 dimensions. So on the y-axis is the number of candidates. As we go down, we're increasing the number of candidates. On the x-axis is the available supervision. So as we go right, we have more and more supervision. And we can see that in all cases, there's a decent fraction of time that we're able to actually surpass that first stage oracle. That's great. But as the number of candidates increases, that is harder and harder to do, because when you have more candidates, what happens is that you have more chance to decode something that's out of all of those candidates, which has a higher rouge. So the oracle goes higher and higher. So that's why surpassing the first stage oracle goes down as we increase the number of candidates. And also when we increase the supervision, typically that would push up the performance of the first stage candidates. So that's also why when we go right, we see a slight decreasing trend. We also have some fine-grained analysis where we would break down the entire test set across several dimensions, and split data points into bins across these dimensions, and then in each bin compare the performance, like once again the baseline, the Pegasus baseline, and the new model summa fusion. So those four features that we're using is the summary quality, right? So that would be the rouge achieved by the Pegasus top bin, the candidates diversity, so how candidates overlap with each other, the source length, and the compression ratio. So compression ratio is the average length of summary candidates divided by the length of the source, which is another dimension we can analyze in summarization. So how much do you want to compress? Are you talking about writing a long summary or a very short one? So for instance, on exam, the compression ratio is very small because you're compressing to a single sentence. And we see a few patterns as well here. So what we notice, and that confirms our previous intuition, that summa fusion was helping you more in 10 shot and 100 shot in complicated cases, in cases where you have a bad initial pool of candidates. So when the summary quality is lower, right, it's more noticeably above the baseline. And actually, interestingly, when the summary quality is high, summa fusion would not help and would actually harm a little bit. We also see a small pattern that's relatively better on longer source documents and on more diverse candidates, which this pattern holds on Reddit as well, right? See a sharp performance improvements on the lower quality bins, top left, and it holds on Samsung as well. And on Samsung, yeah, we see some greater relative performance improvements with a greater compression ratio. I mean, with smaller compression ratio, so a greater compression density. Right. So to conclude this study, so we introduced summa fusion, which is a new paradigm in second stage abstractive summarization, which consists in fusing summary candidates together. In a nutshell, summa fusion encodes Pegasus diverse beam search summary candidates, as well as the source, all of them independently with another BART model, and concatenates the representations from the source and each candidate into a unique long context vector, which will be decoded into a new summary. To summarize our analysis, summa fusion improves a lot on complicated data points. So typically in few-shot setups, in lower quality base candidates on longer source documents, or more diverse candidates, and with more compressing data points. And humans notably prefer summa fusion summaries over Pegasus one. That's the end of my presentation. Thank you.
Okay. Thank you. Thank you so much, Mathieu. So this is the last slide, I guess.
Yes, it's 24. Yeah, the rest is references.
Yeah, thank you. Thank you for the presentation, Mathieu. Well, it's not my field though, so it's quite complex for me to understand so many things. Yeah, some terms and terminologies are although familiar with me, but the overall concept is quite interesting, I guess. Although I didn't understand everything. So, but maybe some participants, you know, the audience, they might be working in this field, basically NLP and summarization and all these things. So maybe if they have any questions, they can directly put the questions. They can unmute themselves and can directly forward a question. So
hello. Yeah.
Is there?
Go away. Here is I have I have one question. And and I noticed that you mentioned the ChatGPT and something ChatGPT. Actually, we know that ChatGPT can show its advantage across different NLP tasks, and also in some scenarios it cannot outperform some task specific models like maybe some translation, some summarization. And however, we can leverage the prompt tuning. Have you heard the prompt tuning or fine tuning these techniques? Yeah, for like prompt tuning, we can leverage prompt tuning to improve this task this downstream task performance, the performance on these downstream tasks. And what's the advantage of your solution over this prompt tuning solutions?
Okay.
So if I understand correctly, so you mean prompt tuning of ChatGPT to make ChatGPT better at the abstractive summarization?
Yes.
Okay. I mean,
Gawi might be asking about like prompt tuning in your model, Gawi, if I'm not wrong, right?
Yes.
Yeah.
Like prompt tuning for some GPT models like ChatGPT. Oh, yeah. And you know that recent many prompt engineering works focus on how to improve the GPT models performance.
Right.
Yeah. I mean, this is one of those new research avenues that was opened with those foundation models, right? With ChatGPT, starting from GPT 3.5. There's around 6 months ago, there's a large paradigm shift, and models are suddenly becoming super good in zero shots. That's why I referred to this at the beginning of my presentation by saying, okay, if you don't know what summarization is, just take any news article and give it to ChatGPT and give TLDR at the end, and you'll honestly, I've done this just a few times. You get something which is a decent summary, which definitely questions a lot of the opens new questions in this field of abstractive summarization. No, I've not personally gone beyond this and try to find the best possible prompts for ChatGPT. However, this research that I'm doing is second stage sequence level abstractive summarization. Technically, you could apply this on top of ChatGPT. right? Because all you need is like an existing set of summary candidates, which you can generate with ChatGPT. You can, there's an argument, n argument. You can ask it to output 10 different summary candidates. And as a matter of fact, in my latest paper, I'm doing this. I referred to it here. All right. So in some score papers, it's going to appear at ACL findings this year. In that one, we're ranking candidates in an unsupervised manner. And also, so I'm using Pegasus, but I'm also I've been trying this on ChatGPT. So of course, like unsupervised Pegasus is quite low. With standard models, like in unsupervised setup, they were really bad. But now what's new is that with ChatGPT or GPT-4, it's unsupervised, right? We're not fine-tuning these models. We can't. They're too huge, and we don't have access anyway. So we do everything in a unsupervised setup. We just ask it, like just prompt them and apply them. So their baseline is much higher. But I'm seeing some quite good gains with the unsupervised ranker. And there's no reason we could not also apply Summa Fusion on top of that. I haven't, because Summa Fusion was published before this was done. It was done last year before ChatGPT. And one issue is that we need to run inference to get a lot of candidates on a lot of data points. That's quite expensive with OpenAI. But if you want, you could apply this second stage method on top of the foundation model. So just that your starting points, instead of using the Pegasus summaries, which I've talked about here in this presentation, which what I had done. There's absolutely no reason you can't use ChatGPT. And also an experiment which would be interesting would be to make ChatGPT a Summa Fusion, right? You could also generate summary candidates. So either with Pegasus or with ChatGPT itself, and then gather them and then give them again to ChatGPT and ask it, okay, now fuse these ones into something better. Like try again, give it another shot, so that then it's becoming similar to chain of thought reasoning a little bit, or you're breaking down the task by asking it to first generate, the first attempt at generation of candidates, and then that's what Summa Fusion is, right? It's more like you give the model another shot at relearning the task and regenerating summaries. So yeah, those would be interesting experiments to run. I would say it's quite complementary, right? There's this second stage summarization research and the ChatGPT and foundation models. They could go hand in hand and benefit from each other.
Yeah.
Yes,
Mathieu, just an interruption here. What is this second stage modeling means?
So in that case, it means when a setup in which you assume you already have an existing first stage model. You already have a model producing summary candidates. So like a BART or Pegasus, which you fine tune on your data sets. So that's the first stage model. And in that case, Summa Fusion is a second stage because it works on top of that. It receives as inputs the summary candidates, and will relearn a new way to produce a new and better summary. So that's why I've been referring to it as a second stage abstractive summarization model.
Okay. Right. Thank you, Gawe. Thank you for the question, by the way. So, yeah, thank you so much.
I have no further questions and a very good answer.
Yeah. Thanks.
Okay, I would have a question, actually. Thanks for the presentation, first of all. I was curious to know how is the ground truth for the datasets obtained? Like you mentioned, Reddit, TIFO. I have read that some posts sometimes from that subreddit. Who provides the ground truth for that?
I believe that on Reddit TIFO, it's actually the authors of the posts. So actually, this is a great question. So let's go through these three data sets. So because all three of them are very popular in abstractive summarization. So for XSUM, what they did is that they crawled the BBC. So the website of the BBC, and they took news articles and they just chopped off the first sentence and said, okay, this is the summary, and the task with this data set is that we're going to have to predict that first sentence out of the rest. Because the way news articles were written on the BBC was that the journalist was writing a first sentence kind of summarizing what's coming. It's like the header, and then so then it's not a proper ground truth. It's more like a pseudo automatic way to collect labels. On Reddit Tifu, I'm not 100% sure, but what I think happened is that they use that Reddit subset where people write their story. Their Tifu means today I fucked up, right? So they write a blog post describing something bad that they did, like this guy erasing the data when trying to dual boot Windows and macOS. That's the example we've seen. And then at the end, that's the same author will also write like a synthesis, like a short summary, and that's the task we're learning here for this machine learning data set, is that we're trying to predict that short summary that the author wrote at the end out of the blog post. And SamSum is quite different, because SamSum, they explicitly ask human annotators to write the summary out of the conversation. So they collected conversations, and then they just hired annotators and paid them to write like a very high quality abstractive summary of the conversation. So SamSum is actually smaller. It's only 14,000 training data points. But like all the models are generalizing super well. You saw it was reaching 52 Rouge 1, which is a very high score. Because it's a very high quality. It's a small but very high quality data set. Yeah. So hope that answers your questions.
Yes. So in both Reddit and XSum, the what is used as ground truth is removed, right? So the first line of the article is removed.
Yeah, I mean, it's just the way it was constructed when they crawled that website and then built a machine learning data set, which you can load on Hugging Face data sets.
Yeah, but I mean if the first line, the header of the article, is used as the ground truth summary, the model cannot see that, right?
Oh, no, of course not. Yeah, of course not.
Okay.
It's not an input. Yeah.
Okay, thanks.
Pascal, thank you for the question. That was really a great question indeed. So is there anyone from the participants who want to ask question here? So if not, then Mathieu, just a query. So like you have these 3 data sets, right? And do they actually satisfy your requirements for the research work? Basically, these 3 data sets in this research work, do they satisfy your requirements?
So could you clarify a little bit what you mean here by requirements?
Requirement is like, for example, you are working in the second stage part, right? So like I was thinking, like, why these 3, basically 3 different data sets? Just one was not enough, or maybe why not like maybe 4 or something like that? I mean, all these different these data sets, XSum, Reddit, Tifu, and then SamSum, they have like different characteristics, I believe. Or are they similar one in nature, or maybe in characteristics?
Oh, I see. Okay. Yeah, thanks. Great question. I should have clarified this, but so basically, I just try to follow, other scientific papers in this area. What researchers typically do would be either you tackle a specific type of summarization, like news summarization. In that case, you pick one or several news summarization data sets and show your model works on those. In my case, the method does not have to, restrict to news summarization. It's technically a general method. So that's why I decided to pick several data sets, not only one, just to show that you can work on several data sets. And I picked data sets of very different nature. So XSum is news summarization. Reddit Tifu is social media or blog post summarization. So you know, the text is very different. You can see, and this is very different from a news article, right? It's it's not the same language at all.
Right.
And the last one is conversation summarization. So once again, so basically 3 very different subtasks in summarization. Summarization is very broad, but here we have 3 datasets each covering one kind of summarization. So news, social media, and conversation. And why these 3 specifically? Because well, these 3 are among the 10 most famous, first of all. So it's easy to compare it to previous literature. And also because they are highly abstractive. And so high abstractiveness. So it means that the ground truth, so what we're trying to predict, right? So you know, here in that Reddit, for example, so we're trying to predict that bottom sentence, right, out of the source. Well, that bottom sentence has many words and expressions which are not in the source. So it's that's abstractiveness, right?
Right.
You have to make the model create those new words, imagine and understand new concepts, which just like a human would do, right? So it's not only just highlighting inputs, words, and stacking them together. So yeah, so that's why I picked these 3, and why not 4? I mean, yeah, after I run out of ideas of another 4th good data set, so I stick to 3.
That's fine. That's fine. Yeah, thank you, Matthew. Thank you so much. And I personally really enjoy it, and I hope all the participants actually enjoy it. And we're going to upload this video so that, you know, researchers around the world can view this one. And I'll be pretty sharing this video to some of my friends who are not, I mean, who are abroad actually. So they will definitely get some benefits from your presentation. And I really wish you good luck for the thesis and this PhD work. Mathieu?
Thank you so much. Thank you for having me today, and thanks for your great questions. If anyone has further questions or just wants to chat about abstractive summarization, I'm always very happy to do so. I believe you can easily find me on LinkedIn or by email. Please don't be shy and just message me. I'm always happy to talk about abstractive summarizations.
Yeah, and I will also share the video to all the participants here. And all the participants, thank you so much for attending this wonderful talk. And because of all of you, we have been able to, you know, invite some of the best researchers. I mean, all of us are really, really good in doing research, I believe. And yeah, presenting the work, and it's really fantastic. I mean, we see a lot of works that are really contributing in the field of computer science and engineering. Mathieu, thank you so much once again. And to all the participants, thank you so much. And I will catch you in the next SLS Talk 28. Thank you so much, and have a great day ahead. Thank you, everyone. Thank you so much.
Thanks, everyone. Bye-bye.
Yeah, bye-bye. Bye-bye, everyone.
Bye.
Bye-bye. Bye.